So with that being said, in the first lecture here, I'm going to be talking about applying the basics of the scientific method. And so what I want to do first is just remind you of some of the foundational matters that I discussed in the first lecture. And so as we discussed in that first lecture, application of the scientific method to answer a business question really requires one to first of all identify the research question as precisely as possible. You want to ask a question that is actually answerable. The second step is then to create a model or framework that really captures the essence of your question. And what you're doing here is you're trying to identify the variables that are involved, in particular, as we'll talk about, the independent and dependent variable, as well as what you think of, what you hypothesize is the causal pathway connecting those two variables. And then once you've done that, you want to translate those concepts into a study design. And once you have that study design, what you're going to do is you're going to collect and acquire the necessary data, and then conduct the appropriate statistical analyses, and then analyze and interpret the findings of those statistical analyses. And a lot of this course is going to be spent discussing those three issues, in particular the various forms of statistical analyses. But this kind of gives you an idea of where it fits in with the overall research picture. And then lastly, once you've analyzed and interpreted your findings, you want to think about how to communicate and present those results to stakeholders in a way that matters to them. Okay, so in this lecture, really I'm discussing the nuts and bolts of the scientific method, including the basic language that's used when we're conducting research. And so first of all, you should know there are primarily three different types of studies. The first type of study is merely a descriptive study. And so these studies are not surprisingly designed primarily just to document what's going on in the data and what exists. And this falls into the realm of descriptive statistics. The next step, and these types of studies typically build on each other. The next type of study is a relational study. And these studies just look at associations between two or more variables. Are variables related or correlated in any way? And then thirdly, typically when you're answering business questions, what you want to know has to do with cause and effect. So you're looking at causal studies, which are designed to determine whether a particular variable causes or has an effect on some other outcome variable. For instance, would offering free valet service at our hospital improve patient satisfaction? And so an important question here is, what are the core features of a causal relationship between, say, variable x and variable y? Well, there are three things to know. If x is the cause of y, then first of all, x has to precede y in time. So we have to have temporal precedence. Secondly, x has to be statistically related somehow to y. So there has to be some degree of correlation or association of the cause and effect. And then lastly, thirdly, and this is usually the trickiest part, we have to be able to rule out other competing alternative explanations. So there can't be other plausible alternative explanations for the reason why x might be statistically related to y, other than that x is in fact the cause of y. Okay, so time is another critical element of research design, and here we come to a fundamental distinction in types of research studies. One type is referred to as a cross-sectional study, and this is literally a study that takes place at a single point in time. It's a slice or snapshot or cross-section. Typically, this is a survey that asks people about both the outcome variable and the independent variable at the same point in time. The second kind of study is referred to as a longitudinal study, also sometimes referred to as a cohort study or panel study. And here we're looking at the same measures at least two or more different points in time. And so this is a study that takes place over time. And so you're measuring the same participants on at least 2 separate occasions. For example, a survey administered before and after an intervention would be an example of a simple longitudinal study. So another thing to talk about are variables. A variable is any entity that can take on different values. And so, for instance, biological sex is a variable, and variables can have different attributes. So an attribute is a specific value on a variable. So biological sex is a variable with 2 attributes, male and female. And when it comes to talking about variables, there are 2 types of variables in particular that we're interested in. One is the independent variable. So this is the variable that you're interested in testing to see if it has an effect on something else, right? This is the thing that we think is the cause of some outcome. And so often this is the variable that we manipulate. For example, offering a program intervention to offer valet services to hospital patients would be the program, offering the program would be the independent variable. On the other hand, the dependent variable is the variable that we presume to be affected by the independent variable. So it's the effect and or the outcome. And for instance, in this case, hospital patient satisfaction scores could be a dependent variable that are affected by some program, such as offering free valet service at the hospital. And so when it comes to thinking about relationships between variables, there are several different types of relationships. And first of all, when we talk about the nature of a relationship, there are 2 distinctions here. The first kind of relationship is a correlational relationship. So here we're talking about association, but not causation. So that just means that 2 variables are somehow related. In statistical terms, there's covariation between the 2 variables. When one moves, we see a movement in the other one. They're not totally independent of each other. The second type of relationship is a causal relationship. And so this is, these are 2 variables that are correlated, but in addition, one variable causes the other. And so it meets the 3 previous criteria for causal relationships that I outlined in a prior slide. Another thing to think about has to do with patterns in relationships. And so there are 4 possible options here. One option is just that there's no relationship between 2 variables. And so you can see the diagram on the bottom for 0 relationship if the x-axis were the vertical axis there, the independent variable, and the y-axis, the horizontal axis, were the dependent variable. If there were no relationship between the 2, then you would see that flat horizontal line. Another option is there's a positive relationship. As x, the independent variable, increases, then y, the dependent variable, increases. And so that would be the line increasing on a 45-degree angle from the point of origin there. Another option is a negative relationship, and that merely means as one variable goes up, the other variable goes down. So they're strongly related, but they're negatively related. And then lastly, there's the possibility of a curvilinear relationship. And so this is when the 2 variables are positively related to each other up until some sort of point after which they begin to be negatively related to each other. And so these are 4 basic types of patterns that you might see in relationships between variables. So when it comes to scientific relationship, some other very important things to consider are the data that we use and then the unit of analysis. And there are 2 basic types of quantitative data that we're going to be talking about. One is numerical data. And so you can think of variables such as age or hospital expenditures. These tend to be continuous numerical variables. But there are also other types of variables that are categorical. And so they don't take on a continuous range of numerical values. For example, gender or biological sex typically takes on 2 values, male or female. Another would be college diploma status. So did you graduate from college, yes or no? That's a categorical data. It's also important to note that sometimes researchers take numerical data such as, for example, personal income, and then convert it to categorical data. So you could create strata. So does a person make between 0 and 50,000 would be one category. 50 and 100,000 would be another category. More than $100,000 would be the third category. And so it's possible to convert numerical data to categorical data. The other important thing to pay attention to is the unit of analysis. And so this typically is whatever entity you're analyzing in your study in the data. And so oftentimes we'll talk about individuals or patients, and that would be one unit of analysis. Another unit of analysis is when you're looking at just overall values for a group. So that, for instance, you might be talking about just comparing hospitals to each other using overall values for those hospitals. And then thirdly, another example of a unit of analysis would be a geographic unit. For example, a county could be a unit of analysis for a geographic unit. Okay, so now let's talk about the research question. And so this is very important to be able to know how to ask research questions. And most research originates from some general problem that we're trying to solve. For example, if we were working at a hospital and our executives, our bosses might be very concerned with the fact that Medicare is adjusting our hospital payments based on patient satisfaction, and we need to improve our patient satisfaction scores or we'll get paid less money by Medicare. And so that problem should then be narrowed down to a specific research question that can be answered. For instance, we may want to know what the effect would be of offering free valet service to patients on our hospital patient satisfaction scores. That would be an example of a research question. And the research question then becomes the central issue that is going to be addressed in our study. And it must be possible to then operationalize that research question into testable research hypotheses. And so a hypothesis is a specific statement of prediction that describes in very concrete terms what you expect to happen. And typically what we do is formulate two mutually exclusive hypothesis statements based on our research question. So the first hypothesis statement is called the alternate hypothesis, and this is the hypothesis that supports your prediction. For example, based on our previous research question, offering free valet service increases hospital patient satisfaction scores. That's something we can test. The mutually exclusive alternative is referred to as the null hypothesis. And this is the hypothesis that describes all other possible outcomes. So in this case, the null hypothesis would be offering free valet service has no effect or actually decreases overall hospital patient satisfaction scores. One thing to note here is that you can have either two-tailed or one-tailed hypotheses. If you look at the hypothesis I've asked here, this is actually a one-tailed hypothesis because we're predicting that offering free valet services would increase hospital patient satisfaction scores. And so we're stating the direction of the effect. A two-tailed hypothesis is just saying that there would be some effect. So a generic effect that could either be positive or negative. So if we were specifying that, then a two-tailed hypothesis, we would say offering free valet service impacts hospital patient satisfaction scores. And then our null hypothesis would simply be that it has no effect on overall patient satisfaction scores. All right, so now I want to return to our case study when it comes to applying the scientific method, and I'm actually going to ask a question in the assignment related to applying the scientific method, not in this exact case study, but this provides a nice example. So if you recall, our research problem is that we need to increase our hospital patient satisfaction scores. Our research question that we came up with based on that problem is what is the effect of offering free valet service to hospital patients on patient satisfaction scores? So what type of study is this that we would be conducting? Well, this would be an example of a causal study because we're arguing for hopefully a cause and effect of free valet service on patient satisfaction scores. When we're thinking about time, this is a longitudinal study. Why is it longitudinal? Because we would need to measure patient satisfaction both before and after the intervention, because we're testing to see if offering the intervention of free valet service leads to an increase in patient satisfaction scores. So we would need to test that at least 2 separate time periods, meaning this is a longitudinal study. Our independent variable would be offering free valet service to patients, and our dependent variable would be hospital patient satisfaction scores. The nature of the relationship here is causal. At least we certainly hope that's the case, and we'll be testing for that in this instance. And the pattern in the relationship here would be positive. So at least we're hoping. So we're hoping that offering the free valet service leads to an increase in patient satisfaction scores. The data type here, for the independent variable, our data type is categorical, right? Either people will receive or they will not receive the free valet service. And so that's a yes-no binary categorical variable. However, the dependent variable is a numeric continuous variable because those are patient satisfaction scores, and those can vary along a dimension. I believe typically the way Medicare measures those is from 0 to 100. Our unit of analysis here is individual patients. So this is a little tricky. You got to think about it because we want to know if our intervention affects patient satisfaction scores at our hospital, but we're looking for the impact on individual patients because it's individual patients that are offered the free valet service, and it's individual patients' satisfaction scores that is going to be in our data set. And so our alternate hypothesis that we're constructing here is that free valet service increases patient satisfaction scores, meaning our null hypothesis, which is the mutually exclusive alternative, is that free valet service makes no difference or decreases patient satisfaction scores.